So here's the problem. A ship must travel from point A at 0, 20 to point Z, C at 80, 50, and also pass through point B along the x-axis anywhere from 0 to 80. So basically the ship can take any of these paths along here. Now the problem asks three things. First, find this point B along the x-axis where the total distance of the route is maximized. And second, find the point or points where the angle made by ABC is a right angle. And lastly, find the point along the x-axis where the total distance of the route is minimized. So here's how I went about solving it. First, I wanted to look at what the total distance of the route would look like for various points along the x-axis. So how I did this was I found the total length of the route at any given point by adding up the lengths of each of these sections here. And so looking at each part here as a right triangle, I can use the Pythagorean theorem to find the length of this side here, and then in this other triangle find the length of this side, and then add them together to get the total length. And so plotting this for every point along the x-axis here from 0 to 80, I ended up with this shape here. And so as I move my B point here, you can see how the length kind of changes here. And the formula, see, it's length of this segment here, AB, plus the length of the segment BC. And so, just from this, it's already easy to see the answers to part 1 and part 3 of the problem. The maximum distance is clearly at 80 right here, where it is 132.462 approximately. And then the minimum distance is found kind of at the bottom of this arc here. So to find that point, I could just look at where it has it here, but also I wanted to take the derivative of this curve here and find where that equals 0, because the only point where the derivative of this equals 0 between 0 and 80 would be the minimum here. And so right here you can see I take the derivative of my length function, which gives me this curve here, which is kind of hard to see, but that is the derivative of this. And so looking here where this crosses the x-axis, I can see that my minimum distance for the total path is found when my value of k is equal to 22.857 here. And here, you can see the value of d, the total distance here, is 106.3, and if I go up a little bit, that goes up 106.4, or if I go down from that a little bit, 106.4, it goes up, the total distance increases on each side, so I know I found the minimum. Okay, now for part 2, you find the point or points where the angle ABC is a right angle. So, to do this, I looked at it kind of right in here, and I saw that the angle between these two is equal to 180 degrees minus the angle here, and minus the angle here. And now, because I know the side length here and here, based on my value of k, and then side length here and here, based on my value of 80 minus k, I can take the arctangent of each of those to find the angle, and then subtract those from 180 to find the angle in here. So you can see I did that right here. So this is the angle of this triangle right here, multiplied by 180 over pi, because Desmos puts this in radians and I want in degrees. Doesn't really matter. And then this is the angle of this triangle right here. And so subtracting each of these from 180 degrees and plotting it from 0 to 80, you get this curve here. And so looking at this, the angle here gets shallower as k approaches 0, as you can see in the curve here, and its maximum around the middle or so, which you can also see in the plot, and then decreases again. So somewhere in here, it looks to me like there are 2 points where it hits 90, because over here, this is clearly less than 90 degrees. Over here, that's clearly less than 90 degrees. And in the middle, it's more than 90 degrees. And so because my angle values are plotted on the y-axis here, all I had to do to find that was plot y is equal to 90. And so now the two intersections here give me my values of k where the angle is 90 degrees. So if I go to this one here, approximately, see that that appears to be right angle, and looking at the angle here, it is indeed approximately 90 degrees. And then if I go to the other one, all the way over here, see again that it is approximately 90 degrees. And so these points are at 15.505 and 64.495. Alright, so here are all of my final answers. Most of these were already shown, but here it is again. So the point at which total distance is maximized is going to be at x is 80. In this case, k is 80, which would be all the way over here, because that maximizes that. And the total distance at the point is 132.46 approximately units. And for part 2, the points where the angle between them is a right angle, those are found at 64.495 and 15.505. And the point at which the total distance is minimized is found at kind of the bottom of this curve here, which is at 22.857 units.